We have the pleasure of having here with us our colleagues from the Technical University of Berlin. It's Professor Eike Roswag-Klinge and Professor Andrea Klinge from ZRS. It's an architectural office in Berlin, and at the same time at the Fachhochschule Northwest in Switzerland. They have a long-term experience in designing and constructing with nature materials, and they are here to present to us their experience, the experience that they have gained over these years in the use of material, the architectural principles, the methods that they are using for the design, how these materials can be reused, and a little bit about the regulatory framework in Germany, so that we can get a little bit better acquainted with what happens in Germany, a country with a longer tradition in eco-friendly construction in comparison to Greece. And I would like to invite Professor Eike Roswag-Klinge and Professor Andrea Klinge to make their presentation.
Well, thank you very much, Maria, for the very nice introduction, and also the opportunity that we can share our work, our knowledge, and also our questions that we still have, because I think in the construction industry there's a lot going on at the moment, and we try to develop solutions, but it's not that easy, and also sometimes to us answers are still missing. We start. As I said before, we're going to share a little bit the project. I think full screen is missing still, right? And we structured our presentation in a way that we give you a little bit of an insight what's influencing our thoughts behind the projects that we develop. We're going to quickly, show you a few projects, one related to the greenest research project that Maria was presenting already, and then we will also give you an outlook where we stand, what's the challenges in terms of legislation. So I call it motivation, but it's probably more the current situation in construction, or the current situation that we're facing in Germany. We're all talking about the Paris Agreement, and that we should not hit the 1.5 degrees of temperature increase. And in Germany, we had the very, very sad news at the beginning of the year that during 2023, the entire year was above 1.5 degrees. And that doesn't maybe sound that bad, and I always try to compare. It's not just the temperature increase in the sense that the air temperature is rising, it's more something what would happen to the ecosystems. And if we compare us as an ecosystem, if our temperature, body temperature increase would be 1.5 degrees, you can imagine what's happening there. Thank you. The other issue that we have is, you might know this organization, Country Overshoot Days, or Overshoot.org. They calculate the resources that Mother Earth is providing us overall in a year's time. And the calculation here is that if everybody in the world would live as in a certain country, resources would deplete at a certain day. And I've just highlighted Germany. It was the 2nd of May this year, where all the resources, if everybody would live in the same standard as in Germany, the resources that we would have available for 1 year would have gone on the 2nd of May. If you could calculate it overall, the Earth Overshoot Day, so the entire population of the world, this year it was the 5th of June, and you can probably imagine that every year we're hitting an earlier day. So this graphic is telling us quite clearly that we have to consider the resources that we use in overall lives, but this also relates a lot to construction. This is, again, a very sad situation as we see it in Germany. Probably it's similar in Switzerland. In Greece, I was told we're facing a lot of demolition. And the figures here, you can see the mineral resource consumption related to the construction industry in Germany is 92%. So most of the resources that we extract goes really into the construction sector. Then we have, as the image is showing us clearly again, 55% of the construction, but also demolition waste. So we're demolishing buildings a lot earlier. And if you see the picture, the way we constructed in the past 60 years is not in a way that we are able to retrieve materials as we did in the past. I mean, we've seen the oldest house here today in Athens, and you could see where the stones were reused, timber was reused, and so this is all gone as a knowledge and as a thinking. And obviously material extraction, the production of construction materials, but also heating up buildings cause a lot of CO2 emissions. This is what Maria was referring to already. So this 40%, it's the smallest figure, but this is obviously giving us a headache, and we need to bring this down. And this relates at the moment mainly to the production of construction materials. So we need to find a way how to overcome these issues. This is maybe a little bit of a boring graph, but this is also for us is quite important. It shows the cost evolution in architecture in Germany again. And what we are facing is obviously a cost increase. This is also due to increased expectations and standards, but there's a difference between what we put into the construction of the building and what we put into the building services. And you can see the average cost increase also with labor costs is sort of like 50% between 1999 and 2019. But if we look at the building services, how to heat and operate our building, it's nearly 70%. And we always ask the question, did the quality of the living spaces or the spaces overall has increased by that? And we feel no, it hasn't. So we put a lot of kit into our buildings because we as architects, we lost a little bit the knowledge how to design a building properly. We design often glass facades, and then we ask the mechanical engineer how to resolve the issue to keep it hot in the winter time and to keep it cool in the increasing heated summer month. So this is what is really concerning us in our office, what we discuss with our team, but also with the research teams from the university. What is architecture able to do in terms of all these problems? So we see that through the detection of oil, all of a sudden we could construct higher and wider, and we could construct these glass facades, but this is obviously not going into the right direction. And knowing that we are still having an increasing world population, but we know that our resources are depleting, the question is, how does architecture from tomorrow look like? So what we did in the office, and we're still progressing with the scheme because it has not reached the final end probably, we try to develop a building system that is able to address such issues. And this is based on historic construction. It's always good to look back in history, because when there was not so much technology, people knew how to construct. If the access to material was still quite difficult because we didn't have all the machinery, people knew how to connect materials together in order to rescue them and safeguard them from a different building. So the thinking behind is really, we look at the historic construction as a wattle and daub house, so it's timber and earth as the main materials, because we know that these houses have been quite comfortable. So they have been quite warm in the winter time, but they've also been cool in the summertime. And this is what we used as a construction system, but to translate it into modern construction. So we use a lot of timber where we can in the structural support system. We try to avoid basement constructions, because for basements and elements that are connected to the soil, to the ground, we always need concrete. We know that the emissions, CO2 emissions related to concrete are quite high. So if you avoid car parking spaces below ground, then you can do a lot for climate positive buildings. We use also a lot of earth where we can. In this building, in this image, it's more related to a high inertia in the internal partition walls. We have a glazing ratio that is not too high, that relates to the orientation of a building, but also to the location. So in south, in Greece, you would probably have less window openings, whereas in cooler climates where you also need to bring daylight in, you can open a little bit more, but these glass facades are really difficult. And then we obviously try to implement renewable energy sources in order to heat our spaces and also in order to provide electricity. So this is a little bit where we come from, and this is what we try to implement in our projects, and in certain we achieved more, in others we achieved less. It's always also a little bit the debate with the clients, and at the end of the day sometimes also relating to cost. So we show you now different projects, two of the office and one Eike is showing you also what we are gonna evolve in the greenest project. So the first one is a school building. It's an extension to the brick construction that you can see in the rear. It's a two-story building, and it's located in the north of Berlin. And when we started with the design development, we were talking to the local authority that we actually wanted to construct the building slightly higher in order to minimize the footprint of the building. But due to the regulation of the urban planning, we were not allowed to construct higher. So that's why we approached the local authority and said, why don't we think about a building that's dismantlable after time? Because maybe in a 50 or 100 years' time, we have a different density in the north of Berlin because the city is still growing. So the idea behind this overall concept is to be able to dismantle the building if it's needed. So the local authority was quite open for this, because for the planning it's a little bit more time that you need, and it's obviously then also a little bit more cost. But they said, okay, overall we will gain a lot out of this concept, so we buy into this idea. So we started first with the overall plan. We can see here a skeleton construction. This is always very good in order to extend also the lifespan of buildings, because you're much more flexible with the organization of the ground floor plan. You have only a few stiffening walls, but the rest of the walls are then very flexible, and you can create different floor layouts. So this was the first idea, and then also to have non-load bearing facades that you could change. For instance, if you, in 50 years' time, maybe there's the need of more residential schemes, then you could change the facade, because the current facade might not relate to residential buildings. We avoided a basement. We had a floor slab made out of concrete. We didn't achieve to go for recycling concrete at the time. This was a cost issue. It would have been better to use recycling concrete in order to avoid new aggregates for the concrete, but that was not possible. But what you can see here is also already the structural system with as a skeleton, and also the entire organization. So the planning was a little bit more time consuming, but then the assembly on site was really, really quick. So the entire structural support system was erected in 20 days. So at the end of the day, it pays off to have this more thinking in the planning process, and to have it then quicker constructed on site. And then I'll show you just a few details that we developed together, or that our engineers actually developed together with us, also being inspired by a EU research project. This, for instance, is the connection of the columns with a floor plate that you can mount on the ceiling, and we have only, it's laid out in the way that we have only vertical loads, and it's just a stacked connection, and it's that simple to place it together and to detach it if necessary. The same was developed then for the beams and the main and the secondary beams. So again, you can imagine it's very quick on site to be installed. You have to secure it through screws, but you can dismantled it again after 50 or 100 years' time. So we developed a lot of these details in order to be able to dismantle, and despite such reversible connections, we still were able to create quite large spans. So the span from column to column is 9 meters, and you can have still very flexible and large-scale spaces. Also for the facades, and this is also what we try to implement now in the Greenest project, we developed a facade system, rear-ventilated, again on the basis of timber. We brought in wood fiber insulation, and again you can dismantle the facade because often the facade is not as durable as the structural support system, or you need to make changes to the facade, and that this is also doable. The idea here really with the weatherboard was to use actually waste wood and to employ the students to mount this facade, but this was something that we unfortunately didn't achieve. But this would have been quite a nice idea also for the idea of reusing timber to bring this in a smaller scale already in the project. This is how the building looks like today. So we have an appropriate glazing ratio. We have night time cooling. So these louvers, timber louvers, are screens where you can open the window. So it's really good in order to provide a good environmental climate in the summertime. It doesn't overheat, and we can still protect the building from birds or any animals entering it during nighttime. This is how the spaces look then finally. We try to make as much timber visible. So the fire regulation is, the fire concept is calculated in the way that the building can burn, but it withstands sort of like a structural decay, so that you can rescue all the people in case of fire. And the other issue is you reduce the amount of materials that you need for additional cladding, and in addition we have a vapor active material that's, as timber is able to store, absorb and desorb moisture. So the building was then actually constructed without a ventilation system. So this is really the benefit of exposing timber, and using earth in such projects. Just to show you what we achieved, this is a so-called life cycle assessment that we carried out. In green you can see the actual building, how it was constructed. Below it's a conventional building that we sort of like assumed being constructed in concrete, and we did this calculation for the global warming potential on all the different elements that we have, for the foundation, for the walls, interwalls, external walls, for the ceiling and the roof. And you can see that the overall performance of the timber building is not that much better in comparison to the other one. But if you consider that we can dismantle the building elements and we don't burn it, but we reuse it and we store the carbon for another cycle or for another cycle, or at least we keep the building for much longer in the first instant, and then we reuse it, then we have really this carbon storage saved, and this is then almost sort of like making up for the CO2 emissions that we still emit as we need to have a concrete foundation. So this is a bit the thinking behind, and this is how we hope to promote such constructions in order to bring the CO2 emissions down to zero. So Eike is now explaining the next two projects.
Okay, so we come to two more projects. One is called Holz-Ziegel-Lehm, that means timber, brick and earth as construction materials. What is a research-based project, what is built for the Berlin-based communal housing association Stadt und Land. And we have a huge consortium of the design team in the core, and then a research team from three universities. We have a little bit of a research fund for that. So we started in the design phase, developing these projects together with the design teams. So ZRS was the designer, and together with Bruno Ferti-Marquez, what is also a Berlin-based office who are very experienced with housing and brick buildings. And we as a team of very experienced with earth and timber. So that's a site plan. We have these two very small piece of land, what is kind of not very good to build on, and we have brought in these two buildings. What the southern one is going to be a brick building, and the northern one is going to be the timber building. Here you can see the ground floors. In the upper line you can see like the black lines in the center. This is a load-bearing cross, and then you can see dots in the facades outside. That's a skeleton, and everything what is in gray could be changed afterwards. So that's what we call the infrastructure of change for a timber construction. And in the lower part you can see the black lines. This is a completely built-in brick construction. So we're going to compare these two buildings. Actually, Stadt und Land, they were talking about the robustness of these buildings from the early 20th century, where we have been building with brick and timber, and very solid buildings. They last very long, and they can also very resistant against the climate. And we always promote our low-tech system, as Andrea showed you, from earth and vapor-active timber construction. And so we're just comparing these two systems. In these details, you can see on the left-hand side the timber details. So we have a CLT ceiling, we have a laminated beams and column structure, and then if we fill it in with natural fiber insulation and have an outside facade and back-ventilated facade. And we have from the inside, we do have earth plastering or earth dryboard panel to have the cover be done. On the other hand, you can see the structure as we started it in our design phase. It was a brick facade or brick outside walls, and then a timber ceiling, CLT ceiling. And by construction issues or design issues, and also the cost, we decided at the end to do the ceilings not in timber, but also do them in brick and concrete mixed construction. So the most important thing that we are trying to reduce our resources and to design kind of a circular construction. And we did start our LCA calculations, and we compared a number of systems. So we have three timber systems. One is the most natural based is H1, the first layer, and then we have one what is caused through the nowadays regulations. So we have additional claddings with gypsum boards because of fire protection. So there's a law, I could talk about this very long. And then we have the lowest one, what is not a timber facade, but a metal facade, because the fire brigades, they said we cannot enter the building with our standards safety technology, so we just have we don't have a timber facade, what actually could be possible, but then they said no, we don't like it, and so now we have a metal facade for that building. And on the other side you can see the brick, what is filled with perlite. I don't know, it's a mineral, light mineral perlite as insulation material, and then the standard wall, but it's our benchmark, it's a conventional one, it's Kalksandstein, it's lime sandstone with mineral wool as insulation and concrete ceilings. And then we did calculations. Actually, Julian could answer these questions because he's doing the research on that project. And we start from the left, that is our conventional building, and we have one two different calculations. The dark one in the front, you can see that's the module A, like the installation phase of the building. And module C is then if you take down the building. So you book off the CO2 again. So you can see the standard building for sure is the most emission building. What is in the erection phase about 250 kilogram per square meters in total. And then you have the brick building with the brick ceilings, and we have a wood roof. So there's a little bit, going down below the black line, what is the zero line, so there's a little bit of a sink of CO2 just from the roof. And then the next step is very big, so that would be the brick and timber construction, like the traditional Berlin houses. What is not built, so the second one is going to be built. And then we have the three timber houses. There you can see we can start at the best one on the right-hand side. That's offering a deep sink of 100 kilogram CO2 per square meter, if you sum it all together. And then you have these gypsum boards, but are not changing the LCA so much, but the metal facades is just half of our sink. So that's a lot of impact if we change these systems in that manner. So we propose to do really 100% natural fiber buildings. And this star is maybe not so easy to understand. There's a line in the circle in the middle from dots. That's a zero line. Everything what is going into the core is a sink, and everything what is outside is CO2 emissions. So we have from 4 to 15, this is always one building. So one is the conventional, from the outer line is the conventional construction. The second line is just showing how these buildings are going to build in the different squares. So we are comparing different buildings in 3 squares, two in Berlin and one in Bremen, where they mention that is timber construction squares. But you can see with the way they are going to build it, with all, reduction of timber, so we are crossing around zero, so that we could imagine in the erection phase they are kind of climate neutral. And if you do everything what you can do in timber, except from the foundation slab, so then you can also come into a little sink. So some people in Germany, they say we can change the world if we construct with timber. That's showing that it's not the case. We can make buildings better. So for sure we need to work with timber, but we cannot change the game. So we need to stop building. That's what Andrea didn't tell you in our starting phase. So now we're going to show the projects a little bit. There's 2 stories of the timber construction. It's prefabricated elements. Unfortunately, the slab took us a while to construct it, so the carpenter had the time, like 2 months or 3 months, to prefabricate the whole building, and then they very quick started to bring it up. So in the center you can see the cross-laminated timber structure giving the solid static of the building. Unfortunately, at the time, they all have to be cladded with gypsum, what you can see here already. Like 2 years ago, we could have built the whole thing in timber without any cladding. So that's what we did in an older project in another case. And then the high insulated wall of timber frame is covering the whole structure and giving the shape. So that's the kind of infrastructure of change what we would mention to have for the future. That's from inside. That's the ground floor. There's a piece of concrete to come out of the water level, and then the rest is the timber structure. You can see still the covered walls in the center, and then the timber ceiling that is visible in the future. So that's how it will look at the end. We have earth plasters and earth dry boards on the walls, and timber ceiling and timber flooring. And in comparison, that's the brick house So it's a complete reddish house, and it's completely built stone by masonry, and so it's a totally traditional way of construction. It's very nice to see how to compare this prefabricated installation and the masonry works here. So they started something like 3 months earlier, and after 2 months of construction, now our timber building is quicker done than the brick building, what will be finished in January. And that's just a top view. Here you can see the CLT ceilings on the right-hand side and the red installation of the brick concrete ceiling on the other side. I think I have to speed up a little bit. So that's our pavilion in Berlin, what Sina is working on since how many years now? I think 5 or so. That's a museum called of transdisciplinary place where we have where we can connect our research with the society. And we entered that project on a certain point and tried to bring in all our research questions and to build with like a real life lab, to build what we are developing in research in parallel. And we don't have a long time of development and then go into practice. So we then decided so that's the place where it is located. It's in a small parking lot behind of the big main building of the TU Berlin and in the center of the campus. And the main question was to build the whole building as a translocatable. So we try to build the structure in a manner that we can take it apart and build it up on another place, like with 100% of our materials. So that's, for our perspective, would be the highest level of circular construction. And we try to build everything out of materials as an option. So we are sure that we are building any element of the building in 1 or 2 pieces, just to show that the whole building could be constructed from waste. And if we can generate more material, what we hopefully will do, extend the number of reused materials in the case. So we will not construct with cement or steel, or fresh cement and steel. So we are having also a recycling foundation. We have a flying foundation that we don't touch the ground. We don't need so much concrete on the slab. And we can start building the ground floor slab with timber as well. And the whole thing is a low-tech building, so it will be without any ventilator. So there will be no ventilation systems. And we designed climate design-based for the building. Also, this textile shell will support our climate design. And that's how it will look. So we will have a 12-meter span of beams done out of waste wood, and then also we have additional this flooring, what will come back later in a little. What is also another research question here, that we have a recycling flooring. These are the 2 floors. You can see these main halls here You can see 3 big halls and exhibition halls in the cafe and the ground floor, and in the first floor in this separation we have a little bit of an office space, what you can see here in between. So it's around 1,200 square meter building. It's not a pavilion, it's more like a solid building. And we changed the whole way of designing, so we are always working on an eye level. We developed the situation through the hands of the students and in interaction with the designers, with the research partners from all the research different perspectives. And then we handed over the thing into a general designer team. Here you can see like a standard design phase where we have the development phase on the left-hand side and the concept design on the second phase. That would be the standard. So we involved our students with a lot of studios from landscaping, civil engineering, etc., exhibition design, etc. And then we developed this concept design, and in parallel we started discussion with our research teams working on the TU, and we started also like going into acquisition to get also research budgets to be able to, have this frame of safety around the construction phase, that we are able to design something what is not possible at the day. And then from the early beginning, we started collecting timber and experimenting in a 1-to-1 level, started all the cleaning and repairing process, did 1-to-5 samples, we did own studio with 1-to-10 samples. All these models are 4-meter wide spanning models. And so that's how our students then develop kind of these structures. Here you can see the final product, what was then in a separate studio where we brought all ideas together and then handed over this final design as a concept design to the design team. And in parallel, we continued collecting timber and experiencing how we can, where we can get, how we get it logistic-wise, what all we have to do. And we developed storage of a little bit of timber here on site, where we just can offer and discuss, offer information and discuss with people from the university and have a place to rest there for lunchtime, etc., etc. And then, we started another phase now recently that we are scaling up. So Sina found a way of funding for the economy senate in Berlin. So they're offering to finance startups. They're usually thinking on digitalization and drones and all these things. And we thought we also should bring in the recycling or reuse process from construction site as a startup, as a real lab. And so we won the first phase, and so we scaled our collection of timber. We professionalized our procedures, how to collect and how to document the materials, and we brought in a lot of material, what we are now processing, what is already processed. And so now we are going also to start first glue lamps from waste timber with a factory in northern Germany. And then that's the research topic again from Greenest in Switzerland, what will focus on a screed from earth, what is not possible to be used in Germany at the moment, and it's a new way of construction with that. So that's something what is on a very early technical readiness level, but we try to implement it in a protected area in our pavilion. It has a little bit of a risk to fail, but that's something what we would as a university accept, just to bring up our research and make it more quick. So now I'm handing over to Andrea.
So just a few things again, where we at with the construction of natural building materials, and to give you maybe a little bit of an outlook or perspective. With timber, we are already quite advanced, I would say. There's, in a way, there's a race going on. So every country tries to construct higher. I'm not sure if this is the way to go, but it shows that timber is a really good element for construction, and to convince people to use it, I think it's important that you can prove that you can also design high-rise buildings. So we did the left one, this competition entry that we didn't win. The building on the right is at the moment being constructed in Hamburg. It's going to have 18 stories, 65 meters high. Fire regulation is always the limiting issue, in the sense that you need to cover the timber in case of fire, that you have a non-combustible material. The concept of burning pieces of the timber down is not always accepted, but there's a lot you can do already. And timber is a very good construction material when it comes to circular construction, as it's easier to construct or to develop reversible connections, and in addition, as we heard, it stores carbon and functions as a carbon sink. Earth construction, we didn't show you too much. I think this will become part of the second lecture. There's a lot going on in Germany as well. We have 4 product standards, which are very useful for architects because specifying materials that are not standardized or not controlled is very difficult in terms of liability issues. We have a new standard for the for load-bearing masonry, which is very good. So we are able to construct nowadays, or from now on, 4 to 5 stories as a load-bearing construction in earth blocks, where we hope that this will help to overcome also conventional construction, because again, earth is a circular material and the embodied carbon is very, very low. The next one to come, and this is for architects, is always the more interesting construction, is rammed earth, as we can see here on the picture. This was a long time the largest construction in rammed earth in Germany. The walls are 11 meters high. It's still not standardized, so you would need an application in a single case, which makes the whole process of application obviously a little bit more time-consuming and then costly. But our office is also working on a new standard for rammed earth construction, so this is going to be very interesting as well, I think. And the last one, we know that we also have to reuse building materials in order to bring emissions down. These are just a couple of images again. We have guidelines coming out anytime soon for load-bearing elements in timber and in steel, because in a way the fear is always, if you dismantle a building, what's the structural integrity of the building element? Can you apply it again, or has there been a damage or whatever? So we need to have certain guidelines, standards in place in order to assess them. We've done it on the left-hand side. This building was dismantled. We've done structural testing in order to prove that this timber is still reliable, but this obviously is a very time-consuming process. What's also very interesting, and I think Switzerland is really well advanced in Europe in that respect. There are a lot of clients who take over the liability issue, which is always a question. They buy into this concept. Then we have also craftsmen that say, I know what I do. I guarantee for my work, so they don't guarantee for the building element they used or reused, but they guarantee for their work, which we as craftsmen, we like it a lot, because normally you should be able to guarantee that the construction is lasting. And the other issue, the building elements itself, it's really tricky. So if you can't prove it through standardization, for instance, a window is more difficult. There's this idea of insurances that take over the liability for a building element, so that we are able to reuse it rather than to binning it. And also the entire concept of, or the understanding of acceptance, that's why I put this EU building, some of you might know. It's a very, very nice idea. All the windows that you can see here in the second layer of the facade come from all the different member countries, and some of the windows have been 250 years old, so they really try to promote this construction of reuse again, and I think there's a lot possible already, and there are a few obstacles to overcome, but I think we're going to achieve this in the very near future. Thank you very much.